I'm Sandro Barone. I'm full professor of machine design at the University of Pisa.
I am the coordinator of the European funded project PRIME-VR2 that has been granted 4 million euros in the framework of the Horizon 2020 program. The project includes a multidisciplinary team with 14 partners from 9 different European countries. The team consists of 5 universities, 6 industrial partners, and 3 clinical living labs. Our 3-year project has the ambitious goal of developing a full digitized workflow supporting patients' assessment and the design of tailored virtual games, programs, and custom tailored assisted controllers produced via additive manufacturing techniques. The main expected output of the PRIME-VR2 project is the VR IT platform, which includes a digital toolkit for patients' data capture, a virtual reality environment including games and bespoke controllers, which is being designed and developed to enable people with stroke and sports or hyperkinetic movement disorders to participate in therapeutic virtual reality games. The clinical level labs anticipated by embedding therapy and opportunities for the acquisition of skills in an enjoyable and stimulating environment. Patients will acquire a higher dose of therapy, improve their progression towards recovery, and acquire skills in the virtual environment that can be transferred to real world. Halfway through the project, the partners have already achieved remarkable results. We have designed and developed a user data toolkit for the assessment of patients, which is typically performed manually and with analogical tools before starting a rehabilitation therapy and also in between. The toolkit consists of 3D scanner and motion capture system and holds a force assessment device and is now being tested by the living labs with real patients. The collected user data are used by the user profile toolkit, which generates a biomechanical profile and a set of ergonomic requirements for each user, which is created on the basis of the user's anthropometric data. Multiple concepts have been developed, including a base unit and modules. Besides, we have developed a form-generating algorithm for the creation of 2D lattice structure for the housing. The concepts have been evaluated with the living labs and many samples of the lattice structure have been 3D printed for testing their performances. The third task is meant to study how to design the controller components, considering that some are specifically designed for a user and that they must be then assembled. 3 functional prototype controller devices have been developed and the optimal assembly routine for each controller has been developed and tested. Another task concerns the study and the development of the controller electronics, hardware, and software, which fit the controller and satisfy its requirements. Results are ready to be integrated with the controller prototype for testing. The last task concerns the development of the virtual reality platform and of the game environment. 10 games have been designed according to the collected requirements and have been proposed to the living labs for the assessment and selection of those that will be implemented. The tools implemented are being extensively tested and evaluated by real patients at our 3 living labs in Malta, Cyprus, and London.
I invite you to visit our website for being informed on project achievements and the latest news.